All right, guys, so in this video here, we are going to look at equations, and we're going to determine the number of solutions that an equation has. So we're working in Khan Academy here, and we have 4 problems that we're going to do. And I think I already kind of started this one. Let me erase all that there. All right, so I'm going to do 4 problems here in Khan Academy, and so we are given an equation here. How many solutions does the following equation have? And our options are no solutions, exactly 1 solution, or infinitely many solutions. So what we're going to want to do is start solving the equation. And there's 3 possibilities that could happen, one of which is you're left with no variable at all. Another one is you could end up with the exact same expression on both sides. So we have some options. Let's just start attacking them, and we'll deal with them as they come along, and I'll explain which of them it would be. So first thing I'd like to do is on this side of the equation, I can combine some like terms. The 9z and the 7z, I can combine those. So I'm going to combine those together. 9z plus 7z is 16z. The minus 6 just stays there, all right? So all I did is I combined this thing and this thing together, combine like terms, equals, and then this side of the equation I'm just going to rewrite, 16z minus 6. And hopefully you're seeing what I'm seeing right away. You're like, whoa, this is kind of unique. The left side of the equation is the exact same thing as the right side of the equation. So the expression is here, and it's equal, it's equivalent to the expression here. What's going to happen in that case is it doesn't matter what you substitute in for z, you're going to get a correct solution. So there is infinitely many solutions to this problem. Choose any number you want to plug in for z, and the left side of the equation is going to be the same as the right side of the equation. So we got infinitely many solutions to this problem here. All right, how many solutions does the following equation have? Same question, and so we're working with a lot of the things that we've already done, things like the distributive property, combining like terms. So we're distributing the 7 across parentheses. We have 7y minus 7 times 8, that's 56, equals 7y plus 42. Notice how this time we don't have the exact same thing on both sides of the equation. This is something different. On the left side, we don't have the exact same thing as the right side, but there is something in common. Notice there's a 7y here and a 7y there. That's important. What that basically tells us is that at this point, we already know that there's no solutions, but let me explain why. Let's just try to get all of our variables together on one side. And so we subtract 7y from both sides of the equation. What ends up happening is we end up with negative 56 equals, these cancel, but so do these. So we're left with negative 56 equals 42. Does negative 56 equal 42? And the answer is no, they don't. Now, if that ended up equaling each other, then you would say infinitely many solutions, but that doesn't make sense. Negative 56 does not equal 42, so there's no solutions. That's how you know something went wrong there. All right, let's take a look at this problem here. Same kind of prompt. How many solutions does this equation have? Let's look to combine like terms first on this side. So I can do the negative 2z and 7z. That makes 5z. The plus 10 just gets brought along for the ride, plus 10 equals, and then this side of the equation, we're just going to rewrite it, 16z plus 7. All right, so this is a problem. We're going to start just trying to balance things out. So what I'm going to do is I'm going to subtract 5z from both sides, kind of like I did in the last problem, right? 10 gets brought down. 16z minus 5z is 11z plus 7. And I can keep working on solving this problem, but I don't need to find the solution. I just need to determine, is it no solutions, infinitely many solutions, or exactly 1 solution? If it was infinitely many, then these z's would disappear and you'd have an equivalent answer. If it was no solution, then these z's would disappear and we would have something that doesn't make sense. But in this case, we still have a z left. And if I was to continue solving and I just subtract 7 from both sides, I get 3 equals 11z. And when I divide both sides by 11, I get a solution. This is a problem that has exactly one solution. The key here is that the z's didn't just disappear. That's the real key here. One more problem here, and we're going to distribute the 13 across parentheses. 13y plus 13 times 3 is 39 equals 13y plus 39. So the left side of the equation is the exact same as the right side of the equation. They're literally the exact same thing, which means that we have infinitely many solutions. No matter what you sub in for y, it's going to be the same thing. Infinitely many solutions. All right, that was only 4 problems, and I don't know how much that was of help, but I'm hoping that something that I said in here helped you out a little bit along the way. All right, keep fighting, keep going through this together, guys. Let's get better.
Do you miss the golden era of rap? Then you need to